Hello and welcome to Working with Variables, a bane or practice. I will be Alex Carlson, yours truly, and we are going to go over the addition and subtraction of variables, or at least the logic behind them. We will not do multiplication or division. Keep in mind, just as a precursor to this, we are not going to be using x for multiplication as much. We are going to be using the regular dot. Okay, just as a quick little teaser here for you. So what are some hidden assumptions that we normally make about problems in this case? Well, the teachers assume that if we give you 2 plus x equals 4, then x equals, drumroll please, bingo. And if we give you 3 plus x equals 5, then it must also be true that x equals, right. If you didn't get 2, no worries. And if x plus 8 equals 20, then it must also be true that x equals, perfect. Now, I understand that we're going a little bit fast here, but in previous videos, we went over the breakdown of how to do this particular set of subtraction. For those of you that need a refresher, then you should be able to rearrange this as x equals 4 minus 2, x equals 5 minus 3, and x equals 20 minus 8. And that's how you get each of these corresponding numbers. Now, when you see these equations, you should be able to do these really quickly because they're easy numbers. If you're not able to do them really quickly, there's plenty of practice available. So, a little logic goes a long way when you're working with variables. In the past, we have given you these huge problems, like 3 2's added together give you 6. Therefore, 2 times 3, wait a minute, I put an x again. Gosh darn it. Let me fix that up for you really quick after adding this 6. I'm going to take out that x, and we're going to replace it with a dot. If you catch me doing it, email me. So, 4 plus 4 equals 8. Therefore, 4 times 2, wait a minute, almost put the x, must equal 8. So what if we took out those 4's and replaced them with x's? So x plus x must equal 8. Now mind you, I replaced the 4's with just x's, so the x's represent the same number. There's no way of getting around that. So can we also conclude that x plus x is the same as 2x? Yes, we can. Because this means that you're counting 3 2's added together. This means you're counting 4 2's added together. Or I'm sorry, 2 4's added together. Depends which way you want to read it. But this means we're taking the sum of 2 x's that have to be the same. Now, notice how I'm putting the dot now. In regular algebra, they don't really care about that dot. So you can say 2x, you can say 3x, you can say 5x, etc., etc., etc. So what if I give you 2 plus 2, and this is an older style problem, so I'm going to give you a slew of 2's right now. It's okay, don't panic. There's a bunch of 2's here. They're very friendly. So 2 2's together is the same as 2 times 2, plus we want 3 2's added together, so 2 times 3. Let's see, that equals 2 times 2, which is 4, and then 2 times 3, which is 6. Therefore, we have 10. Brilliant! Wait a minute. Now we're going to be given, let's see, 2 numbers that we don't know added together, plus the same numbers added together 3 times. Uh-oh. Wait a minute. This is a problem. Because now they're giving us 5 numbers added together, all have to be the same. And we got to find it. Okay. Let's not panic here. So we got 2 x's on one side. We got 3 x's on the other. And, wait a minute. It's just like the previous problem. 2 x's on one side, 3 x's on the other. So therefore we have a total of 5 x's. And that has to equal 10. Let's see, what was the original number that we needed? Let's see here. So if we follow our previous math, x equals 2. Now, algebra is indeed the act of restoring, which means that this is what you're used to. This is what we're doing now. So teachers could just throw out a slew of numbers at you like 2 plus 2 plus 2 plus 2 plus 2, and that would give you 10. And you would have to solve for it accordingly. Well, now we're doing it backwards. Now they're telling us if I give you any 5 numbers that all have to be the same added together, and that makes 10, then you should be able to tell me that that first number is 2. It takes a little bit more work, but it's doable. So how about subtraction? With this, you have to be very nitpicky. So in the past, they gave you 2 plus 2 plus 2 in parentheses minus another 2 plus 2. Okay, let's not freak out. Let's break this down. That's a 6, and this is 4, and therefore you get 2. Or, just like in the last problem, we could say 2 times 3, and we could say, what's the other one? Minus 2 times 2. Let's see, broken down, that's still 6 minus 4, which is 2, so we get the same answer regardless. Let's put this into algebra terms now. We're going to strip out all the 2's and we're going to put them in with x's. Why? Because we can. So 3x's added together minus 2x's added together should give us, wait a minute, hold the phone here, what's going on? Most teachers will go at this pace and they'll go by it pretty quickly, so let's break this down accordingly. We had 2 times 3 on this first side, and then we had 2 times 2. Well, if we had 3x and 2x, notice that this number is not changing. We always have the same number each time. So this is just like saying, well, if I have, let me go into white here, if I have x plus x plus x minus an x plus x, well, in the old days, you would just cancel these numbers out accordingly. So those x's cancel and these x's cancel. So you're left with just a single x. Or you could say 3 minus 2 equals 1. Therefore, you only have one x remaining. So that's a food for thought here. In subtraction, it gets a little more complicated and a little more difficult to see, but just make sure you follow this particular template, that you're subtracting the number in front. You're not taking away x's, you're only subtracting the number in front. So this idea does not work for multiplication, but once again, we're going to do a quick little overview just to show you what we did today. So we said 2x plus 3x equals 5x. True. And that's just because 2 plus 3 is 5. Well, if I say x equals 2, then 4 plus 6 must equal 10. Aha! Proof. Well, not proof. It's more of an equality, but that's beside the point. And if I have 3x minus 2x equals just a plain old-fashioned x, or 1x for those of you who want to keep with the ones, and if x was equal to 2, then 3 times 2 minus 2 times 2 must equal 2. Therefore, 6 minus 4 equals 2. Brilliant! And we are finished with this episode. Again, these are short tutorials on how to get through the basics behind this. And again, have fun, enjoy your day, comments below.